Hello, everyone. Good morning, good afternoon, good evening, depending on where you're based in the world. We are welcoming you to the A4Q Global Testing Summit live from Dublin. I'm very happy and welcome to you, Iosif. We are grateful to have you here as a speaker, and we're looking forward to your presentation. Iosif is co-CEO and co-founder from Exact Pro. And yeah, we're looking forward to your presentation. I don't want to take too much of your time and hand over to you. Thank you for being there.
Thank you very much, Kanana. Hello, everyone. It's a pleasure to be here, and I'm very grateful for the opportunity to talk about software testing at IFAQ Summit. It's my second presentation in this series of events. I'm working in software testing for the last 17 years. I participate in a number of activities related to software testing, in particular in zero outage industry standard and most working group within fixed trading community. I will start with a quick introduction of the work that we do in the area of financial market infrastructures. Then I would like to cover the question of the definition of software testing, how to measure properly software testing, what is required for large-scale agile transformation, who is responsible for quality in financial market infrastructures, and how do we teach it to software testers. Exact Pro is an international company. We employ over 700 specialists. Our main delivery centers are in Georgia and Sri Lanka. I'm very grateful to the president of Georgian ICQB board, Natya Saberladze, for inviting me to give this presentation. And I'm currently in Colombo, capital of Sri Lanka. Exact Pro works with exchanges and clearinghouses, the most mission-critical institutions in financial services. We work in more than 20 countries on all continents, covering the most scalable, latency-sensitive, and reliability-sensitive systems across the globe. So after 17 years in software testing, when I'm thinking about the question, what is the software testing, I'm of course go to Google to look for the answers, and the first links in Google Scholar give us top links with definition as art, craft, research, and in fact people define it as a continuum from art to craft to science, research, and engineering. Some go further and consider it into data journalism or even magic. But let's focus on science and engineering. Lots of vendors insist that their product in software testing is turning software testing into engineering. So what is the difference between scientific inquiry and engineering? There's a great book on nanotechnology called Radical Abundance. This book describes our society when nanotechnology is introduced, and it covers topics relevant to this revolution. And one of the chapters describes the relation between scientific inquiry and engineering design. These two processes go hand in hand. It is not possible to achieve great engineering without sound scientific foundation. And cutting-edge science requires more advanced instruments and tools produced by engineers. So these two processes work on expanding humanity's capabilities. But there is a fundamental difference between them. And the difference is the anti-parallel structure of information flow. Engineering is turning an idea, a model, into a useful product. And scientific inquiry is trying to understand a physical object and build an abstract model of the object. So these two processes exist in parallel, but they have anti-parallel flow of information in two different directions. So what is software testing? In ISTQB, we define it this way. Personally, I believe that giving people confidence and demonstrating something is not part of software testing, as the first principle of software testing clearly states that software testing shows the presence of defects, not their absence. So it is not possible to show that anything fully corresponds to requirements, and it is not possible to show that something fully fit for its purpose, but you can always detect defects and prove their presence. So my preferred definition of software testing is exploring software with the intent of finding bugs. Software testing is empirical technical investigation conducted to provide stakeholders with information about the quality of the system or product under test. And software testing is an information service dedicated on finding things that decrease value of the product or system. Bugs. I believe it is very important. Software testing is related to software development in the same sense as scientific inquiry is related to advanced engineering. Both processes exist in parallel, but they both have anti-parallel flow of information. So in software development, we are taking a model requirement specification and we are trying to build something useful. In software testing, our goal is not to build something useful. In software testing, our goal is to obtain information and share it with the relevant parties. So it is very important to understand that these are two different processes. Development and testing are different things. They are closely related. They should work in parallel, but they differ because information goes in two different directions. So taking into account that software testing is an information service, how do we measure the value of testing? We need to apply the same criteria, the same approaches that we use for any other information services, any other data quality framework. And there are four main principles on how you measure the quality of data, the quality of information service. It is accuracy, relevance, interpretability, and accessibility. Accessibility, information might be there, but if it is not accessible, it is of no value to others. Information can be there, but if others are not able to interpret it, then they are not able to use it. And the first two, accuracy and relevance, are of great importance to software testing. Accuracy stands for our ability to detect important defects, and relevance stands to our ability to provide relevant information to detect defects as early as possible. In financial market infrastructure, looking into accuracy section, there are several measures of accuracy quality, and some people use accuracy, some use precision. We teach that the main thing is in large-scale implementation, mission-critical implementation, is of course sensitivity. So we need to decrease the probability that we miss some important defect. And it is more important in many contexts related to financial services and also in other industries to detect a defect rather than the annoyance of having a false positive of a rejected issue. There is a film about software testing called Pentagon Wars, and there is also a song about software testing called Ironic. If you read definition of what irony is, you will see that it is a definition of what software testing is about and what we need to find. So it is incongruity between the actual result of a sequence of events and the normal or expected result. So of course, software testing deals a lot with irony, and relevance of information differs depending on the context. The song tells about a fly in a Chardonnay that is annoying issue that is not critical. It also covers losing money, and it also covers the things that threaten human life. So in different industries, in different contexts, the relevance of information might be different. And relevance is mostly important for the agile context for testing. In ExactPro, we rely on peer-reviewed paper that defines agility as responsiveness to change. Agility is not following particular rituals. It is whether a person, a team, a company, an industry, or a country can be responsive to change. And we know that currently in the world, the only thing that is constant is change. So if you need to get all BDD files before you can start development, or you are not able to react to changing requirements within your sprint, it is not responsiveness to change. it is something else. And agility is ability to quickly respond, quickly and efficiently respond to change. There are multiple definitions of agile testing. So one of them covers that agile testing is a software testing practice that follows the principles of agile software development. My problem with this definition is that software development is a different process from software testing. So it is the same as to say that agile cooking is the practice that follows principles of agile hunting. So we are talking about two different things. ITQB glossary, we have a better definition that defines agile testing as any testing performed within agile projects and agile development practices. Of course, the fundamental books on agile testing also try to give definition of agile testing, but I was not able to find the precise definition what is agile testing. On the other hand, these works contain very useful and very often used and preferred concept of agile testing quadrants that define what is, so whatever we see on this slide is agile testing. So we have in quadrant 1 things like unit tests. In quadrant 2, we have BDD, specification by example. In Q3, we have exploratory testing. And in Q4, we have things related to technical aspects. So there are two different sides, guiding development and criticizing the product. Let's think about something like unit tests. This is the definition of software. Software is a collection of instructions and data that tell a computer how to work. The computer hardware is able to execute the software. Each instruction causes the computer to carry out an operation, moving data, carrying out a computation, altering the control flow of instructions, or manipulating hardware. So if you look at this definition and then you think what unit tests are, you will see that unit tests are software. So writing unit tests is not doing software testing. Writing unit tests is developing software because unit tests are software. How we view it is two quadrants on the left is building software. BDD, to a degree, is also a set of instructions. You collaboratively define executable specification. And its executable specification, it allows you to run it. And what are you running? You're running software. So what we have on the left is software. And the processes in Q1 and Q2 are called built-in software. On the other hand, processes on the right are testing software. So this is a very clearly defined boundary between these two processes that have anti-parallel flow of information. And of course, for in exactly the same way that good science requires sound engineering to support it, sound tools, the same is absolutely applicable to software testing. So good exploratory or performance testing requires sound tools in order to support it. And we call it build software to test software. So in order to run testing in agile context at scale, it is necessary to have tools that will cover the right quadrants, Q3 and Q4, to do software testing within large-scale agile implementations. Software testing relevance is crucial in agile context. What it means that we have process flow that is parallel. In agile, we need to run software testing and software development in parallel. But always remember that these two processes have anti-parallel flow of information. So how we define whether our software testing activity is relevant to the overall process? It is relevant when the information that it provides is relevant. For example, if we find more defects that development team can process, it means that a number of them might have a decreased value. Or if software development team is capable of building more software, then we can study, research, and identify defects in it. Once again shows that our information is less relevant to the rest of the team because we give this information later than necessary. And timeliness is one of the main features of relevance. So when you build software testing within large-scale agile implementations, it is necessary to make sure that both processes can run in parallel at approximately the same pace. And it requires engineering both in building software and in testing software. Any large-scale successful implementation that we've seen so far has the same features. And there is a very good book that describes large-scale agile development transformation within Hewlett-Packard. It is considered to be a huge success by reducing overall development costs, increasing amount of innovation, and achieving the dream goals of every large-scale agile transformation. We can see that themes relevant to this case study is also present in any case study where we observed a successful implementation of large-scale agile. So among other things, what they did is built a large number of the test environments where information is obtained at any stage. So we have some checks that are executed on commit. There are checks that are executed in a larger environment. And there are large-scale regression libraries that constantly run. So one of the things that you need for optimizing feedback loops in complex large-scale systems is to throw hardware at it, because you need to have test environments where you'll be able to run small unit testing checks, and you also need to have large environments where you are able to cover the system as a whole. And also, if the next version is available, you have two options. You can stop executing a large-scale automated checks, or you can restart against the new version, or you can proceed and take the new version as well and execute it in some other environments. People often refer that they would like to implement the same speed of change as in huge web portals like Facebook and Google, and then it appears that in their agile transformation they have a single test environment. It is not what you do. Achieving anything requires sacrifice, and in large-scale agile, you're buying time with hardware. So the first thing that you need in order to have large-scale agile implementation is, of course, hardware. The next one, the same case study presents very successful implementation. So in their case, they achieved 8-fold increase in time allocated to innovation and 3 times decrease in time on what is called usually manual testing, because most of the checks are automated. But if you sum up the change in development effort allocation, you will see that on the right we have 77%, and remaining 23 are spent on developing and improving automated checks. This is the direct text from the case study. If we look into this 23%, 3% went on test tools, 10% went on scripting checks, and 10% went on failure triage. So you can sum up 5% from most testing is now automated, and 10% from failure triage, and to compare it with original 15% from manual testing. So the second rule of large-scale agile testing is that you are buying time with people. So regardless of how good is your automated test library, the fact that you are producing more information faster means that you need to apply more human brain to analyze it. So the second rule of large-scale agile test and transformation, you need to throw people at the problem. And of course, you need to have a process. So there is a term of cross-functional teams. So when you go hunting in the morning, and then you're cooking in the evening, and then you do everything, everyone can do everything. This process is present in any other area, and in natural economy, natural economy to a degree was a direct implementation of cross-functional team several thousand of years before it appeared as a concept in Agile. But it's not how industry or large-scale research work in practice. In order to have information flow relevant for large-scale agile development, you need to have a process is capable of generating enough information to fuel software development, and it cannot go without specialization when you talk about large-scale implementation. So software testing for large-scale agile development is built on 3 pillars. You throw platforms to buy time, you throw people to buy time, and you also look into the process that help you to understand the system that you're trying to develop and make relevant decisions faster, because sound software testing can provide information faster. We do teach a lot of software testers, so we have several hundreds who passed ISTQB certification. We have several hundreds who are working on example projects. We have lots of courses available in open access. But what is the main thing that we are trying to teach? Often there is a mantra that quality is everyone's responsibility. So everyone means it is also responsibility of all software development and all software testers. As we are looking into the documents that guide how financial market infrastructures work, quality is the firm's responsibility that cannot be delegated or outsourced. You can't contract out your responsibility for quality. And responsibility for quality rests with the senior managers and the executives within the firm. They can allocate resources, they can buy hardware, they can hire and fire software developers. But the main responsibility as the leader is to obtain information and to make sure that you have channels to obtain objective information. So you are not able to delegate it out, to delegate to somebody that somebody else will obtain information instead of you when you have responsibility for quality. On the other hand, software testers do have responsibility, and they have responsibility for quality of their own work. So when we teach software testers, we use 2 very interesting books in this area. One is Extreme Ownership, and another is the Scout Mindset. So there are no bad teams, there are only bad managers. And we teach software testers that they are responsible for everything related to their work. And their work is finding defects. So when there is a defect that leaked into production, there is no one else to blame. It might not be necessarily an industry practice, but it is how you teach testers that if you are not able to find defects, that there is something wrong with what you do. Scout mindset is the motivation to see things as they are, not as you wish them to be. And software testers need to have Scout mindset, and they also need to work with others to help them see the things as they are and provide information about things that decrease the value of the software, about software defects. Software testers have extreme responsibility for finding bugs. And it is what we are trying to teach. Defects are valuable information, and information is the most valuable commodity right now. So when instead of making sure that there is a flow of information, we are trying to cut it up in one way or another. It usually results in a software that contains more defects, no less, because we are trying to see the things not as they are, but as we wish them to be. Testing is measured by accuracy, relevance, interpretability, and its accessibility. In large-scale financial market infrastructures and other mission-critical systems, sensitivity is more important than accuracy or precision. In the Agile context, the main thing is relevance of information. And if you want to get good software testers, you teach them that there is no one else to blame for software defects that leaked into production apart from software testers. Otherwise, human will always find a way out not to take responsibility. And software testers are responsible for the quality of their work, for their ability to identify defects. Conclusion. Development and testing are two parallel processes with anti-parallel flow of information. Unit tests and CI/CD is software. TDD, BDD, Agile testing is software development. Software testing is an information service. Software development benefits a lot from additional information. Agility is responsiveness to change. And quality is firm's management responsibility. It can be outsourced and delegated. Software testers, on the other hand, have extreme responsibility for their own job of finding defects and providing accurate, relevant information that can be interpreted and accessed by others. Large-scale Agile requires investment in software testing in three things. You throw hardware, you throw people, and you throw process targeted to obtain more information to optimize feedback loop within large-scale information. So in essence, you're buying time with money. Thank you. Thank you very much.
Well, we thank you very much for this presentation. And for now, it seems like the audience is happy and we have not received any comments or questions, but they can also reach, or like the audience is also able to reach you via LinkedIn, for example. We tagged you in the stream. So if there are any questions popping up, they can contact you. And otherwise just comment below the video and we can share the question with you so that Iosif, you can answer the question. Thank you for being part of the A4Q Global Testing Summit. And yeah, it was a pleasure.
Thank you. Thank you very much.
Okay, thank you. Take care.